Hey everybody, in the previous video we talked about correlation coefficient and what it looks like, how to describe it from a scatter plot. So if you remember, we looked at linear relationships, we looked at if it was positive or negative, we looked at if it was a strong or a weak relationship. This video we're going to actually calculate the correlation coefficient. So how do we get that number R, or the number that represents R? How are we going to get that number? And I'm not going to make you calculate it by hand. I'm going to show you a couple different methods or apps that we can use to calculate correlation coefficient. So for this one, how can we be sure that the bungee cord we make Barbie will keep her safe? Should you be worried if you use the wrong units, choose the wrong axis, or measured wrong? At the beginning of the year, I would have done this little experiment with you, but unfortunately we weren't able to get together. I'll show you kind of what it looks like, but students will drop Barbie, she'll bungee jump, and we measure like how far she drops based on the number of rubber bands we tie together. So here we have the number of rubber bands, 0 through 7, and then the lowest point her head reaches in inches. So we're going to use the SPA app, and I'll show you what that is. Enter the data to create a scatter plot and calculate the correlation, and then answer the question, how safe do you feel Barbie's bungee jump would be if we use this data? And we're going to use the correlation to justify our answer. So the app, the one app is on StatsMedic, so just statsmedic.com, and under resources you want to go to applets. And in the applets here, we want two quantitative variables. So we've been talking about explanatory variable and response variable. So our explanatory variable is our number of rubber bands. Our response variable is the lowest point her head reaches. So we had 0, 1, 2, 3, 4, 5, 6, 7. I'm just getting this data right off of this worksheet here. And then here we had 12, 14, 17, 18, 22, 23, 26, and 30. I'm just putting commas in between each. And then just begin analysis, and then here is the scatter plot. Okay, so if you had to create some sort of scatter plot or draw it on an assignment, you can just use this and it kind of creates it for you, and then just copy it down. Down here, calculate correlation. So I want to go ahead and press calculate. So my R is 0.992. Another way to do this, so if if we're using, let's say, Desmos, we can do the same exact thing using Desmos. So just in case if you don't want to use this applet or you forgot, I'll post the link in Google Classroom, but if you forgot, Desmos also does that. So all you have to do though to do that is you have to create a table. So X1, Y1, and I'm going to put my information there, 0, 1, 2, 3, 4, 5, 6, 7, and then my Y's are going to be 12, 14, 17, 18, 22, 23, 26, and 30, and Desmos will graph that for you. I'm just going to zoom out here. And there's the data. You can also, like this wrench up here, that toolbar, you can change how you want your Desmos to look, how the screen you want to look. So let's say we're going up to 30, so we can go to by 35s. and then I only need to go by like -1. And then my y-axis, actually, sorry, I don't need to go by 35, I need to go by like maybe 10. And I think that's fine there. So that kind of shows you what the graph looks like. And then we can calculate correlation coefficient. It's under functions, under stats, there's this CORR. So if you just hit that, and I get that functions from the keypad here. So if I just press functions under stats, and we'll get that CORR, that's the correlation. And you have to type in x1, y1. X1, y1, that's from the table from above. They'll use that. And my correlation is 0.992, which is what I got here on this StatsMedic app as well. So just two ways to calculate correlation coefficient. You can either use this StatsMedic, or you can use Desmos. There's two ways to use that, or to do that. So here, so how safe do you feel Barbie's bungee jump would be if we use this data? So I think I would say that our correlation is quite strong. So since our correlation, right, R equals 0.992, sorry, since our correlation is strong, right, R equals 0.992, I think she will be safe. Okay. Our next here, unfortunately, the group had measured the lowest point of Barbie's head in inches instead of centimeters. To fix this, they multiplied the inches by 2.54 because 1 inch is approximately 2.54 centimeters. The new data is shown below. So how do you think these changes will affect the correlation? Verify by calculating the correlation in the applet. So I'm going to show you how to do that on Desmos. So I'm going to actually just keep that data there, but I'm also going to add another table. Notice that it's x2, y2. I'm going to just, let's go ahead and change the color so it's different. We'll just change it to red. And I'm going to get the data right here. So 0 through 7, but instead of in inches, we have it in centimeters. So I have 0, 1, 2, 3, 4, 5, 6, 7. Here I have 30.48. Here I have 35.56, 43.18, 45.72, 55.88, 58.42, 67.04, and 76.20. Okay, so I'm going to just kind of scroll up and look to see this data, making sure I have it all right. Okay, and now I'm going to calculate the correlation coefficient for x2, y2. And I notice here that this correlation for the red data and for the green data is going to be the same. So, no matter if we're in centimeters or if we're in inches, that correlation is going to be the same. So this is what I would say. I would say it is still the same, right? R equals 0.992. Multiplying all the numbers by 2.54 does not change the correlation. Okay. One of the group members snuck some extra rubber bands to collect more data. Add the point 15 rubber bands, 124.5 centimeters to your scatter plot. How do you think this outlier will affect the correlation? Verify in the applet. So like if we remember, like here's kind of what our data look like. And if we have that one outlier, well, let's see kind of what it looks like if I add that to our Desmos here. So I'm going to add one more point. We had 15 rubber bands and it was 124.5 centimeters. Okay, so if I gotta zoom out, there it is. Okay, let's see what happens to our correlation. 0.998. Okay, and actually, so here it strengthens the correlation by making the data form a clearer line. Okay, so our I think we had was 0.998 is what I had. So the next question here, one group member accidentally left off a digit. Add the point 6 rubber bands and then 7.04. So instead of 67 to the scatter plot. How do you think this outlier will affect the correlation? I think this, well, let's see what it.
Okay, so again, I'm gonna take, I'm gonna add the 0.6 and 7.04 on Desmos. So here's Desmos. I'm gonna delete this point. We're gonna add 6 and 7.04. So even if I ignore these like green points up here, and I'm just looking at the red points here, notice that we have this kind of outlier. So, and I kind of drew it here. So how do you think this outlier will affect the correlation? Verify. I would say it weakens the correlation by pulling the line down away from the points. Okay, oh, I didn't, let's look at what is the correlation here. Is 0.4123, 0.4123. So R equals 0.412. So that's something that we could say when we add some sort of outlier. Okay, some important ideas from the text. The first thing, if you change units, the correlation stays the same. Okay. Next thing, if you switch X and Y, the correlation stays the same. Correlation is not resistant to outliers. Therefore, it is affected by it, okay? So if we have one out here, that would strengthen. If we have something that looks like this, with that outlier up there, that weakens the correlation. Okay, let's look at this application. Archaeopteryx is an extinct beast having feathers like a bird, but with teeth and a long bony tail like a reptile. Because the known specimen differ greatly in size, some scientists think they are different species rather than individuals from the same species. However, if the specimens belong to the same species and different in size because some are younger than others, there would be a positive linear relationship between the lengths of a pair of bones from all individuals. An outlier from this relationship would suggest a different species. Here are data on the length in centimeters of the femur, a leg bone, and the humerus, a bone in the upper arm, for 5 specimens that preserve both bones. Okay, so we're going to make a scatter plot. Do you think that all 5 specimens come from the same species? Explain. So here's my data. I'm just going to plug that right into Desmos. So here's Desmos. I don't think we're going to need these anymore. So let's go ahead and we'll do a table, and my X's are 38, 56, 59, 64, 74. My Y's 41, 63, 70, 72, 84. Okay, I can't quite see them. I'm going to go ahead and zoom out. There they are. Okay, so I'm going to go ahead and graph this here. Okay, so I went ahead and graphed this from the Desmos. Right, so here's Desmos, and then I went ahead and graphed this on our notes here. Number 2 says find the correlation by using the applet. Explain how your value for R matches the graph in part A. So again, all you got to do is go to Desmos, and you can type in CORR, and then I've got to type in X1, Y1, because it's got to use the table here. My correlation is 0.994. So R equals 0.994. I would say it verifies that we have a strong positive linear relationship. Okay. Number 3, suppose that a new fossil was discovered. If the femur was 70 centimeters and the humerus is 40, do you think this specimen came from the same species? Explain. So if I were to plot 70-40 here, 70-40 is right down here. This is that new point. I think it seems like it would be like an outlier. So I would say no, 70-40. And if you want to, you can even go to Desmos and plot that point, 70-40. And then look what happens to the correlation. The correlation went down by, it was 0.511 now. So I would definitely say, because it weakens, I would say no. This point is not from the same species, since it is not in a linear pattern. Maybe we say within the linear pattern. Okay, last question here. What effect will the new fossil have on the correlation? Well, we kind of saw exactly what happened. It will decrease the correlation because it pulls the line down away from the rest of the data. Okay, if you have any questions with this stuff, please don't hesitate to ask. Hopefully this is another straightforward video. Don't forget, we do have a quiz on Friday on Edulastic. It's over 2.1 to 2.4, so everything that we learned last week and this week.